so there's the definition of deductive reasoning. Tell whether the statement is inductive or deductive reasoning. Explain your choice. So we've got this graph, all right, and it's showing the number of strokes that it takes a seal to come to the surface from a specific depth. So you look at the data for a second, and now we have this statement. The northern elephant seal requires more strokes to surface the deeper it dives. How can we conclude? How did we come to that conclusion? Go ahead, in the back.
It's because the dots are scattered at random, and they're not like specifically stated.
So what kind did you say it was?
Deductive.
Okay. Anybody else have any thought? What kind of reasoning we're using here? Levi.
They built up facts by showing that the deeper down the went, the more strokes it took.
Okay. So what do we see? What's happening here with the graph? What's it showing? Right.
The deeper it goes, the more strokes it does.
Yeah, we're seeing a trend here. In other words, what we're doing is we're actually observing a pattern. Less strokes, less depth. More depth, more strokes. And so we have an upward trend of the strokes along with the depth. So this is inductive reasoning. You're observing the pattern of the dots. It's going up. It's increasing. So this would be an example of inductive reasoning. Because you make a conclusion based upon the data in the graph. Observing the data. What about this one? The northern elephant seal uses more strokes to surface from 250 meters than 60 meters. What kind of reasoning are we using there? Yes, go ahead. Deductive, right. Why? What are we doing there that clues us in when we're using deductive reasoning? What are we making, Chapman?
Taking observations and using like the data from the chart.
Well, that describes inductive reasoning. I talked about it when we defined deductive reasoning. Okay, we're comparing. We're comparing 250 meters to 60 meters. We're comparing the strokes at those two depths. So when you compare like that, that's deductive reasoning. You're weighing the facts of one against the facts of another. So it's deductive reasoning. Laws of logic. Law of detachment. If the hypothesis of a true conditional statement is true, then the conclusion is also true. The law of detachment to make a valid conclusion in a true situation. So here it is. Mary goes to the movies every Friday and Saturday night. Today is Friday. What can we conclude? Ryan?
Mary's going to movies tonight.
Yeah, Mary goes to the movie tonight. So it's nothing new. We just take from our original statement. She went to the movies every Friday. Today is Friday. So she went to the movies. All right? That's law of detachment. Law of syllogism is like a chain. If P, then Q. If Q, then R. So then if P, then R. The last and the first then go together. right? You're not detaching anything. It's still if-then. You're just then you're just matching the beginning with the very end. If statement A and B are both true, then the statement C is going to be true. So let's see what this looks like. Is it possible to use law of syllogism to write a new conditional statement that follows from the pair of true statements? So you're writing a new conditional with law of syllogism. If Ricky takes chemistry this year, then Jesse will be Ricky's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. What is an if-then? Following that pattern I just described, what if-then could I come up with from these two statements? Trent.
If Rick takes chemistry this year, then he will get an A in chemistry.
Right. He took the first hypothesis and he paired it with the last conclusion. And that's how we get our new statement. Here's another example. Can we do a law of syllogism with this? If a polygon is regular, then all the angles of the interior polygon are congruent. If a polygon is regular, then all of its sides are congruent. Can we do law of syllogism here? No, we can't. Because this is repeated as A twice, right? If a polygon is regular. And then they have it again here. If we were going to use law of syllogism, it would have to be, this would have to become your second if. If all the angles in the interior of the polygon are congruent, then something else. Right? It didn't make the chain. It repeated this one in the same position. So we could not do law of syllogism there. The conclusion, none of the conclusions are the same as the other statement's hypothesis, so you can't use the law of syllogism. Two, 4. Use postulates and diagrams. I'll tell you what. Let's do our in-class practice next, and then we'll come back to this. So, in Canvas is the 2-3 practice worksheet. It deals with the reasoning and these laws. So while it's fresh, let's do it. Go ahead and 2-4, use postulates and diagrams. Postulates are rules that can be accepted without proof. Theorems are rules that are proved. We use postulates to prove theorems. Postulates accepted without proof. Theorems proven. It's frozen for some. Oh, there. It changed on your screen, but it didn't change on mine. Huh. What's going on here? Okay. Postulate 5. Do you have a postulate 1, 2, 3, and 4? Okay, we start with postulate 5. Through any 2 points, there exists exactly one line. I put 2 points on the chalkboard. There's only one line I can draw through those 2 points. Postulate 6. A line contains at least 2 points. If I have 1 point, I can't make a line, right? It's not connecting anything. But as soon as I add that second point, then I have a line. So 2 points make a line. Postulate 7. Now you don't need to know these postulates by their number. In other words, you don't need to memorize that postulate 7 is this postulate. You just need to be familiar with these rules. Understand them. Understand the rules so that you can apply them to things. But you don't have to know its name is postulate 7. Postulate 7 is, if 2 lines intersect, the intersection is 1 point. The line I've drawn here can only intersect the original line in one place. Postulate 8. Through any 3 non-collinear points, there exists exactly one plane. I put 3 points on the chalkboard. The only plane that goes through those 3 points is the chalkboard. Now there's an important word there. It says non-collinear. Because if these points were collinear, then I can draw this line through them. There are an infinite number of planes that go through that line and those 3 points. The chalkboard does, but I could draw a plane horizontal going through or coming out of the chalkboard. I could slice it at any angle and go through that line, a plane. So make sure that you this rule includes non-collinear. That's a good true-false question. They might try to trick you and just say true or false. Through any 3 points, there exists exactly one plane. That's false. Those 3, they're infinite planes. So you have to say through any 3 non-collinear points, there exists exactly one plane. Number 9. A plane contains at least 3 non-collinear points. Okay, very similar to as we talked about with the line and 2 points. A plane has to have at least 3 points. If you just have 2 points, you don't have a plane, you have a line. Postulate 10. If 2 points lie in a plane, then the line containing them lies in the plane. If 2 points lie in a plane, then the line containing them lies in the plane. So I've got these 2 points. They lie in the plane of the chalkboard, right? Then this line that goes through them would also be in that plane of the chalkboard. Postulate 11. If 2 planes intersect, their intersection is a line. Where the wall meets the floor, this cove base, we'll say that's a line. That's the line form. Where the ceiling meets the wall, that strip along the wall, this is the line formed by their intersection. So here are some diagrams. So you have to do some visualization here. Which rule is A? Don't tell me the postulate number, tell me the rule. What is that picture depicting? The if-then of those pictures. Trent.
If two lines intersect, then their intersection is exactly 1 point.
That's correct. What about B? What rule do we have there? What postulate do we have there? Okay, go ahead.
If two planes intersect, then their intersection is a line.
Yes. Two planes intersect, their intersection is a line. Identify a postulate illustrated by a diagram. Which postulate would this one be? What's postulate 8? Go ahead, Kayla.
Through any three non-collinear points, there exists exactly one plane.
I think that would be the one. Yes. Through any three non-collinear would be the word we want to use. Non-collinear points, there exists exactly one plane. Use the diagram to write examples of postulates 9 and 10. So using letters in the diagram, how could we see what? Somebody read to me what postulate 9 is. What's postulate 9? Chapman, read it.
Postulate
9.
right here. Oh, a plane contains at least three non-collinear points.
Okay, a plane contains at least 3 non-collinear points. So using points in the drawing, what could we say? Do we have 3 non-collinear points in a plane in the drawing? Okay, how we could say, what we could say is, anybody? All right, we could say points A, B, and C lie in plane P. All right, they're non-collinear and they're in plane P. That's how I would see it. Let's see what they say. They said it the opposite way. They said plane P contains at least 3 non-collinear points, A, B, and C. Chapman, what's postulate 10?
If 2 points lie in a plane, then the line containing them lies in a plane.
All right? Using the letters in this picture, how could we describe that postulate? Do we have 2 points on a line? Which 2 points, Chapman? You're shaking your head.
D and D.
I don't see a D up there.
Wait, where's that N?
M goes with this line.
Oh,
N is the name of this line.
B and A.
B and A. Okay. So points B and A, what line are they on? Ryan?
BEN? Oh, the plane? Sorry.
What line are B and A on? We name lines with cursive lowercase letters, right? Yeah, they're on line N. B and A are on line N. So we could say B and A are in plane P, so line N is in plane P. That would satisfy postulate 10. Let's see how the author said it. So he said point B and A lie in point P, so line N containing A and B also lies in plane P. All right. Okay, does everybody have it? Given the information, sketch the diagram. Sketch a diagram showing line TV intersecting segment PQ at W so that TW equals WV. Try to do that. Go ahead and do that on your own and then compare it to what I put up here on the screen. This is one of the challenges of geometry, visualizing some type of statement in your mind, being able to put it on paper. Let's take a look. First step, draw T, V. So they drew TV and label points T and V. We need to know where points T and V are. Then we have it intersect. Draw point W at the midpoint of TV and mark the congruent segment. So PQ intersects TV at W, and it's not the midpoint of PQ, it's the midpoint of TW where the W is, where they PQ crosses. So we show those two are the same length with the tick marks. So you would plot W at the midpoint, then you would draw the segment that goes through W and label it PQ. Questions? All right, this one's not in your notes, but we'll go through this here. Which of the following statements cannot be assumed in the diagram? Can we assume that A, B, F, and F are collinear? Can we assume A, B, and F are collinear? Yes.
No, because B, oh wait, never mind.
Are they all on the same line? Yeah, we can't assume that. That's okay. What about E, B, and D? Can we assume that? Eva's shaking her head. Why not, Eva?
Because they're not all on the same line.
Right. It looks like they might be, right? It looks like they're lined up, but there's no line drawn through them, so we can't assume it unless the line is there. So we couldn't say that. What about AB being perpendicular to S? Do we know that? Go ahead. Looks like you shook your head.
Yeah,
Why? How do you know that?
because maybe in
What symbol told you that?
the, right,
Yeah, this little square. That right angle tells you, that red line symbolizes right angle. That square tells you that AB is perpendicular to the plane S. What about CD? Do we know that it's perpendicular to T? Plane T? Is there a symbol there that tells us that? No. It looks like it, but there's no symbol, so we can't assume it. We don't know. There's nothing there to tell us it's perpendicular, so we can't assume it. What about AF intersecting BC at point B? Is that assumption true? Yes, it is. AB intersects BC, which is this line, at point B. So that's good. All right.